Hello, guys. Welcome to Cheenta School of Statistics and Data Science.
So question 11 says that there are two football teams, T1 and T2, who have to play two games against each other. And the outcomes of two games are independent. We are given the probability of T1 winning, drawing, and losing a game. Each team gets 3 points for a win, one for a draw, and zero for a lose, as for a loss, sorry. And X and Y are the total points scored by T1 and T2 respectively after two games. We need to find probability X greater than 1. Now, I have written down what X and Y is and the given information. Now, there's only one way in which X can get more points than Y. That is, either X wins both games, so X ends up with 6 points and Y ends up with 0, or X wins one game and draws another. So X ends up with 4 points and Y ends up with 1. In any other way, say for two draws or one draw and one loss for T1 and both losses for T1, X will end up being less than Y. So for our required probability, that is X greater than Y, you need to consider two cases. Case one is T1 wins both games. So since probability of T1 winning at either game is half and they are independent, probability T1 wins both games is half into half, which is 1/4. And in case two, T1 wins one game and draws another. So that probability is half, which is the probability of winning, into 1/6, which is the probability of drawing. And now the win and draw can come in two ways. That is, the first game can be a win and the second can be a draw, or the first can be a draw and the second can be a win. So there are essentially two ways. So it's 2 into half into 1/6. That is the required probability. So it comes out to be 1/6. And the required probability is the sum of the probabilities in case 1 and case 2. It's 1/6 plus 1/4. So it's 5/12. So P is the correct answer.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Which says that f is a differential function on both the domain and radius of R, and f dash x is greater than twice fx for all x belongs to R, and f0 is equal to 1. And we are given four options. So let us go check the four options one by one. Okay. So first we are given f dash x is greater than twice fx, which is the given condition. So dfx by dx, as written down f dash x. So dfx by dx is greater than twice fx, taking dx to the other side in this step. And then integrating this over the range from 0 to t, we get that ln ft is greater than twice t. So ft is greater than e to the power 2t for all t greater than 0. And again, f dash x greater than twice fx for all x greater than 0. So f dash x by 2 greater than fx, which is in turn greater than e to the power 2x for all x greater than 0. So f dash x greater than 0 for all x greater than 0. Since f dash x is greater than twice fx, which is again greater than e to the power 2x. So f dash x is greater than 0 for all x greater than 0. So fx is increasing in 0, in range x greater than 0. And let me go show you the options once. So seeing the options, we can see that C is correct. And again, A is correct. This is question number 15. X is a random variable with series fx, which is 1 if x greater than equal to 1, half plus x by 2 if 0 less than equal to x less than 1, and 0 if x less than 0. So I've simply written down the series of fx here. Now, let us first check the probabilities of x at the points of discontinuity, which is 0 and 1. So probability x equal to 0 is f of 0 minus f of 0 minus f of 0 is half plus 0 by 2, which is half, and f of 0 minus is 0. So probability x equal to 0 is half. And probability x equal to 1 is f of 1, which is 1, minus f of 1 minus, which is half plus half, which is 0. And differentiating fx with respect to x in the other ranges, we get fx is equal to half if 0 less than equal to x, sorry, half if 0 x, half if 0 less than x less than 1, which is this range, and 0 otherwise, because it's constant above the series is constant above 1 and below 0. And again, we have obtained beforehand that fx is half to x equal to 0. Okay, so we now have the PDF of x. Now we have to check four options, which basically ask us about the expectation of e to the power x and probability x equal to 0 given x less than equal to 0.5. So expectation e to the power x is e to the power 0 into probability x equal to 0, since there's a positive probability there, and plus integrating from 0 to 1 e to the power x by 2 dx, since it is continuous in this range. So e to the power 0 is 1, probability x equal to 0 is half, so it's half, plus we just take the half outside, and half into e to the power x is running from 1 to 0. So it's half plus half into e minus 1. So the two halves get cancelled, and the answer is simply e by 2. And probability x equal to 0 given x less than equal to 0.5 is equal to probability x equal to 0 intersection x less than equal to 0.5 by probability x less than equal to 0.5. And now the numerator actually simply comes out with probability x equal to 0, since the intersection of probability x equal to 0 and probability x less than equal to 0.5 is simply probability x equal to 0. So the numerator is probability x equal to 0 and the denominator is probability x less than equal to 0.5. I have written down probability x equal to 0 here, and it's divided by half, which is probability x equal to 0, plus integrating from 0 to 0.5 the PDF of x in that way. So it's simply half dx. And here I have simply done some simplifications, and the answer comes out to be 2 by 3. So A and D are the correct answer. Question number 4, and I have left question number 4 for the last for a particular reason. So here we are given a matrix A of order 3 cross 4, and we have to find the dimension for the null space of A to the power 2023. So, and I've written here, you have to try with A instead of A to the power 2023. Can any of you tell me why? Like, why can't we do it for A to the power 2023? Because this matrix A is not a square matrix. It's a 3 cross 4 matrix, and thus the higher order multiplications of this matrix, that is A square and A cube and so on, these are not defined. Because for A square, you need to multiply A with A, and A, both are 3 cross 4 matrices. So you can't multiply a 3 cross 4 matrix with another 3 cross 4 matrix. Why it doesn't work with that sort of probabilities, okay? So say X follows a geometric p random variable. Then the memoryless property says that probability X greater than A plus B given X greater than A is probability X greater than B. And in the last class, there was a question that whether this works with this form as well, right? Whether probability X greater than equal to A plus B given probability X greater than equal to A is equal to probability X greater than B. So I'll show you why it's not. Okay. Now, this probability I can essentially write down as this. Right? Because x greater than equal to a plus b is simply x greater than equal to a plus b minus 1, and x greater than equal to a is simply x greater than a minus. Now, comparing these two forms, we can say that this is equal to probability x greater than b, just by considering a as a minus 1 here. So, which is not equal to probability x greater than equal to b. Okay, you can also try this out by simply writing down the two events in the terms of the like the probability x greater than a plus b divided by probability x greater than a, and you can simply write down the PDF at each point and then do an infinite summation and figure it out. But I thought this would be more of an elegant proof in this regard.